Use graphical addition to sketch the graph of f plus g. So f is the red graph and g is the blue graph. Let's notice that f doesn't even exist to the left of where x is -2. In other words, the domain of f goes from -2 to 5. That is the domain for the function f. The domain for the function g goes from -3 to 3. So the domain of the function f plus g would be from -2 to 3. Notice that f plus g is expressed in black in each of these choices, and each one of them has a domain that goes from -2 to 3. So we can't eliminate based on domain. If we were to make a little t-chart that paired the x-coordinates with the coordinates of f plus g, we would notice that when x is -2, f would be a little bit bigger than 1, and g would be not quite as small as -1. So that result would be positive, somewhere between 0 and 1. We'll notice in this graph that when x is -2, f plus g is less than 0, so it's negative. So this is not the correct choice. In this graph, we do have a positive value, so that's possible. In this graph, the f plus g function has a negative value when x is -2, so that is not a choice. This one is also positive. But let's also notice that the f plus g value is a little bit larger than the f value when it should be smaller, because when we're adding g to f and g is negative, it should result in a smaller value, something down here somewhere, which is what we find in this graph. Let's also notice that when x is 0, f appears to be somewhere around 2, and g appears to be somewhere around -1. So if we were to add them together, f plus g, we'd wind up with something close to 1, which is something that we have here in this graph. So this selection then is the one that we will choose as our f plus g graph.